So, welcome back. Today, we are going to talk about a technology that you use every day without even realizing it. That is nothing but Apache Kafka. So, the easiest way to understand Kafka is this: Kafka is like a data superhighway. So, just like highways carry thousands of vehicles every second, Kafka carries data, millions of messages following between systems in real time. So, because modern apps are constantly generating data such as the click rates, views that you are going to see some in YouTube or Instagram, payments that you make daily, GPS updates, searches, and that data needs to move fast, safely, and continuously. So Kafka is the infrastructure behind the scenes that makes real-time apps possible. So let's make this idea real with one of the best examples. Think about Uber for a second. So every time when you open Uber, you instantly see cars moving on the map. Not one car, sometimes hundreds or thousands updating live. So the big question is, how does Uber track thousands of cars in real time? So each driver's phone constantly produces events such as location updates every few seconds, speed that way that particular driver is moving on, the direction that driver is traveling on, and the ride status of the driver. Now multiply that by thousands of drivers and you get an non-stop stream of data. And Uber does not just need to collect that data, it needs to process it instantly so the map stays accurate. So that is not normal database problem, this is a massive real-time streaming problem. So and this is exactly the kind of problem Kafka solves. To understand why this is big deal, let's zoom out. Is only one example. The truth is, in today's world everything generates data. So phone generates events, laptop generate events, bank cards generate transactions, cars generate GPS signals, factories generate machine sensor readings, and all of this data comes non-stop. So at every millisecond, okay. So the challenge is not only collecting this data, we need to capture it instantly, we need to organize it, we need to store it safely, we need to deliver it to multiple systems with no delay. So that's the challenge why Kafka exists. Okay. Kafka was not invented because it is trendy. So it was invented because a company faced a real crisis, that is nothing but LinkedIn. In the early 2010s, LinkedIn was growing very fast. Each every click created data, profile views such as messages, connection requests, searches, and the data uh, that became huge and which couldn't handle the scale. So these caused a data traffic jam, delayed messages, system slowing down, data loss, frequent failures. So the LinkedIn realized that we need to have a new system designed for extreme scale. So and this is where Kafka began. So let's see how Kafka was created. This slide shows Kafka's origin. So LinkedIn's user activity was exploding, creating millions of events every day. So the issue is nothing but the traditional messaging tools were slow, fragile, so hard to scale, and they sometimes lost the data. So in January 2011, LinkedIn engineers made a bold decision. So that is nothing but we will build our own system from scratch. So that system became Kafka. So Kafka was designed to be fast, scalable, reliable, and built for failure recovery. So Kafka wasn't a small improvement, it was a new architecture. So now let's understand Kafka's main idea. So Kafka works like a central hub. So instead of systems sending messages directly to each other, which became messy actually. So Kafka sits in the middle and becomes the meeting point for all data. Okay. So think of Kafka is like a CD hub. So everyone sends messages to Kafka first, then Kafka make those messages available to wherever whoever needs them. For example, if you order anything from Flipkart, some central hub will be Hyderabad or Bangalore. So from Bangalore, the shipment will be shipped to your location. Same like Kafka does the thing in particular data entry. Okay. To make this super easy, here is the best analogy that I am going to discuss. If you look here, the left side, there is something but the old way. So traditional pipelines are slow and fragile, okay, which can be easily broken. If one service goes down, messages gets lost. Okay, it is the smallest. It's like a small leakage pipe. Okay, so if you see the right side, so that is nothing but Kafka. So Kafka is like a wide highway, fast, scalable, and reliable. So Kafka is built for high traffic and system failures. So and it scales by simply adding more servers. That is what you need to remember. This is the key slide. So Kafka is like a post office. Just think of. So mail doesn't go directly from sender to receiver. It goes to the post office first, collect it and store safely and store organized, and then picked up by the right people. So Kafka works the same way. So producers send messages into Kafka. So Kafka stores them safely and consumers pull them when they want or when the message is required. So Kafka is not a delivery truck. Kafka is the safe central storage and distribution hub for every data entry. So now let's open the post office and see the Kafka parts. So Kafka is powerful but not complicated. So there are only 4 key components. One is producer, another one is topic, the third one is broker, and the last one but not least consumer. So let's break down. Producer is anything that creates data and sends it to Kafka. For example, Netflix app producing viewing events, that you are watching any movie, that viewing events will be produced. ATM is producing transaction events. When you go and insert or check the balance, every transaction history will be stored. So Uber driver app producing GPS events. So producers create messages and Kafka receives them. Now where do these messages go? That is the thing you need to think. So let us go to the component 2 of Kafka. So if you look at it, if you look here, a topic is a category or channel where messages are stored. So some examples I may give you, like payments, GPS tracking, user clicks. So Kafka stays organized by these topics. So and topics are split into partitions. So Kafka is scaling trick. Okay, partitions allow us parallel processing, high speed, better scalability. So this is how Kafka handles massive loads. So now who stores all those data physically? Now that is the main question. So let's see. He's a Kafka server. So the machine that stores and manages the data. So a group of brokers working together is called a Kafka cluster. So clusters allow Kafka to scale, to stay available for if a server fails, and to replicate data for safety. So and now who reads the data? That is what the main question. So a consumer is any app that reads data from Kafka. Okay. So for example, I can give some examples here. Fraud detection, consuming payments events. Okay. Analytic dashboards, consuming user activity. Uber app, consuming GPS tracking. So Kafka allows multiple consumers to read the same topic at the same time. So that's one of Kafka's biggest powers. Okay. Now let's connect everything into one flow. This is Kafka journey in 4 steps. So that is nothing but producer send a message to a topic. So and broker stores it inside a partition. Consumer pulls the new message. So consumer processes it and does action. So that's Kafka is in one simple loop. Send, store, pull, process. Okay. Kafka powers are the apps we use daily. So one is Netflix, Uber, banks, delivery platforms, even e-commerce. So Kafka makes everything real time. So let's start with Netflix. So when you use Netflix, every action produces data, which means play history, pause history, even browse history, and even like history. So millions of users create millions of events. So Kafka collects these events and stores and shares them with multiple systems instantly. Okay. So when you press play, Netflix produces an event. So Kafka stores it and then multiple consumers read it. Consumer 1 updates continue watching. Consumer 2 updates the recommendation engine. So one event powers multiple actions in time. So now let's see, uh, let's move to Uber. So if you look here, Uber has drivers around the world. So each driver sends GPS updates every few seconds. This creates a non-stop river of data. Okay. So Kafka handles it by collecting and streaming that location data reliably. Okay. Now, drivers are producers in this particular example, sending location messages to Kafka. Okay, Kafka stores those updates in topic like GPS underscore tracking, because this is one topic, because drivers are sending their location, right? So this is stored in one topic, GPS underscore tracking. So then your Uber app consumers in it for real time maps. So then analytics consumes it for traffic, demand, surge, and even dashboards. So Kafka makes real time Uber. Okay. So Kafka is powerful but not for every job. That is what you need to remember. So Kafka is best when you need real time streaming and even high volume of data, even if you want reliability and many systems reading the same data. That is where Kafka we need to use. So but Kafka also brings complexity and as well as infrastructure needs and DevOps management. Okay. So if you look here, I have given some strengths and limitations. So Kafka's strengths are nothing but high throughput, and it is high, which is having high scalability, and which is also fault tolerance and even durable storage. So the limitations are nothing but complex configuration, and we need a skilled DevOps required. Okay, and also we require heavy infrastructure and overkill for small apps. So Kafka is beast, but it's a serious tool. Okay, to wrap up, okay, Kafka is the central nervous system for a modern data driven company. Okay, just like nerves connect the brain to the body, Kafka connects all systems with real time event signals. So now the big idea is with Kafka, data can flow anywhere instantly. So what's next? So Kafka allows companies to build real-time analytics, fraud detection, even also can say recommendation engines, event-driven architecture, and smart automation. So Kafka does not just move. Okay, Kafka enables the future of